Okay, this next group of questions here are going to lead us to an idea that will help us calculate binomial probabilities in a way that is as efficient as possible. So let's think about the basketball player in the last example, and let's say in the second half of the game he attempts 4 free throws. If considering a success to be making a free throw, what are the possible outcomes? So again, we're going to attempt 4. Okay, so how many different numbers of free throws could he make? So he could make none of them. He could make 1. He could make 2. He could make 3. Or he could make 4 of those free throws. Those are his only possible outcomes, anywhere from none of them up to all of them. If we add up the probabilities of making 0 free throws up to all of the free throws, all 4 of them, and we add those probabilities together, those are all of the possible outcomes, so they have to total 1, which is 100% of all of the outcomes added together. Okay, so keep that in mind. So let's say we want to find the probability that a player makes at most 3 free throws. Okay, at most 3, remember, means a maximum of 3. So what we would want to calculate is the probability that he made 0, 1, 2, or 3 different free throws. That's what we would want to calculate. Now remember how long each one of those binomial scenarios is, and we would have to set up that choose and the probability of success and the probability of failure and the exponents being the numbers of probability or of successes and failures. We'd have to set up 4 of those and add them together. Okay, now indeed, that is a whole lot of work. So can we do that without requiring quite so many calculations? So if you go back and we look at the equation that we wrote for adding all of those probabilities together, okay, notice that right here, let me turn on the highlighter here. Right here is what we want. That's the probability of 0 through 3 free throws being made. Now notice if we subtract the probability of making 4 free throws from both sides of the equation, what we end up with is the following: that the probability of making 0 or 1 or 2 or 3 free throws is the same as 1 minus the probability of making all 4 free throws. It's just rearranging this equation here because that probability of 4 cancels out when we move it to the other side. This will let us do 1 binomial scenario as opposed to 4 binomial scenarios. You are free to add up all 4 of the 0 through 3 successes if you want to, but it's certainly going to be faster to calculate the 1 scenario we're not interested in, making all of the free throws and subtracting from 1. Now, thinking along a similar vein, what if we want to find the probability he makes at least 1 free throw? Well, at least 1, and again, I'm just going to jot these down since we're getting started with this concept here. At least 1 is a minimum of 1. So what we're looking for, a minimum of 1, is 1 to 4. That's what we want to calculate. Now you can again add up all 4 of those scenarios, or you can come along instead and you can subtract the 1 scenario we're not interested in this case, which is the probability of making no free throws, and you will find that the probability of making at least 1 free throw, so from 1 to 4 free throws, is the same as taking 1 minus the probability that you make 0 free throws. What is the most efficient way to make that calculation? Well, if you're going for most efficient, you're going to want to do this 1 minus the probability of no free throws. That is definitely going to be the most efficient way to go about this scenario.